2 years ago, we started in Philips Research to explore if we can build a workflow capability in our software platform called HealthSuite platform. And why did we do that? We talked to a lot of solutions in Philips, and they all have implemented workflows as part of the solution. Some have used BPM already to model their workflows and implement them in the systems. Others were doing it in source code directly or had their own proprietary ways of modeling workflows, etc. And we thought we should be able to make a generic solution of that and offer that in our HealthSuite platform, where in Philips all or at least most of the newer applications are built on top of. So we started thinking about it, and by no means we were an expert on BPM nor aware of this community. But soon after we started thinking on this, we hit upon the field guide for shareable clinical pathways that you published, and we recognized a lot what was written there. And that's how things basically got started. So what we were thinking of is what you see, a conceptual design you see here on the left of the slide, and this is also what we are implementing and exploring how useful such an implementation is in the applications that we built in Philips. And the whole idea probably sounds very familiar to you, is that we want to load at the bottom part here workflow definitions as data to a system, so not implement them as part of the system in the source code, but load them as data. And you see BPM CMMN mentioned here, but also HL7 Fire has certain definitions for that. And we wanted to leverage off-the-shelf engines that could execute these definitions. And what you see here are examples, Camunda, JBPM, but as you know, there are many more out there. And we also experimented with a few others than just the ones mentioned on this slide here. But then at the same time, we found these engines to be too abstract on an interface level for our applications, because we are working in the healthcare domain, we're building health solutions. So having an interface on top of that, which is based on an interoperable standard in the healthcare domain, would make more sense than the standard interfaces than these engines like Camunda, JBPM are offering you. So we wanted to have an HL7 Fire-based interface on top of that to communicate to the applications in the end. And the whole idea is that the applications that we built would no longer implement the workflow themselves, but they would load that in the service underneath here, the workflow capability as we called it. And the interaction between the application and that workflow capability would be purely through Fire resources, Fire objects, etc. And this is what we have been exploring. On the left, you see some key design constraints. I will go quickly through them. So the aim is to be able to offer shareable and configurable workflows to our solutions. And yeah, if you load them as data, it becomes much more configurable and shareable than if you implement it in codes. Based on international standards, we don't want to do anything proprietary because we do integrate and interface a lot with non-Philips products, obviously, and also there we would like to be able to leverage the same workflow capability. Also, it will help us in the software maintenance and lifecycle if we can use some off-the-shelf components like a workflow engine here. And this sounds very familiar to this audience, of course. We were also happy to see that we were not the only ones thinking in this direction, but many others, especially this community, were doing the same thing. And last but not least, we also want to make the facility where you can learn about the performance of the workflows actually, so that you can use your AI tools and your data analysts to learn and optimize the workflows in the future. That's a quick summary. This I will not go in detail, the time does not allow. But we started off with looking at all our requirements that we have from all the different solutions, and we compared modeling languages to each other. And the conclusion we draw from this work, and the many details behind this table, is that actually the BPM plus Health method, as described in the field guide, is very suitable for the set of requirements that we have as well. So we have continued with that in our further work. And Patrick will take over here to share a bit on the prototype that we have built. Patrick?
Okay, thanks, Bas. I'll shortly explain the use case. In this particular case, we take medical protocol that we got from an external body, mostly that is in the description in a PDF format. That will go to the hospital, and the hospital wants to transform that to the local situation based on their experience of staff or the situation at the location. And our aim is to get that protocol then at the bedside to the caregivers, as seen here as an example, maybe on a tablet or mobile phone or whatever, that they can see what actions to take at what moment. So I'll go to the next. So what will we do? We created that model. In this particular use case, we used the Cavienne engine. That is an open source CMMN engine. And the nice part of open source is that we were able to add Firepath to it as the expression language. What you see over here is that we define then the full workflow in the model. We translate it to all Fire objects that we, via the Firestore, communicate with an application, and the application can then render a user interface tailored to the situation in the hospital. Here you got an example of an acute care system, but the rest of the example will be more for an emergency department example. I have taken that example from a white paper that I found on the internet, added some information that we got from a local hospital, but by no means that is a full or complete sepsis protocol. So I have to apologize by the medical educated people, but just to show what is possible. We'll go to the next one. Okay, so the first step that we take on the highest level is that, we have contact information as a patient. We put that in as a data object. And the system says we have two phases, phase 1, phase 2. Phase 1 is all the preparations that you do in the first hour when you detect that there is a sepsis. And phase 2 is then reacting on all the information you got later on and try to resolve the source of the sepsis and to get away with that. If you want to translate that to a fire part, can take the next one. We see that we want to start a plan, a care plan. The black parts are the requests that the application is given to our system, indicating from, hey, I want to run that use case based on that activity definition. And the red parts are then the part that is replied by the workflow capability, indicating, okay, I have started an instance for you, and I have currently two tasks, tasks 7 and 16. And if you go to the next step, you see also that we have one of those tasks is completely written out in Fire. It is the phase 1 and with some information where and what to do with that. And if you provide that to the application, then they can render a user interface and say, okay, I have two tasks for you, phase 1, phase 2, and we can continue with that. Okay, for the next. If we dive into phase 1, I see that we have 3 subtasks, and they will then also be all put over in Fire and rendered over on that system. Okay, next. One of the things that we also added was sometimes you want to have extra information, context information of a particular task. I can normally add it to the documentation part of the particular task I put in the model, in the CMMN model, and then that is also transferred in the Fire object, and we can put it here available. If I say, give me the extra information, it will show you. Next one. Of course, there's also a behavior behind it. Over here, we want to show, if I tick in the, go to the prepare task, has 3 subtasks. And if I have completed them all, I tick them all off as completed. And if I complete one of the tasks in the application, it will put the status back in the Fire resource taken up by the engine, and then it finds out, okay, my prepare phase is completed, and I automatically also go to the next step. And as the last part of this demo, we also want to show that even in CMMN, you can make dependency of tasks. So we show over here that the two tasks start and monitor fluid challenge and also the monitor diuresis, they can only start after the administer vasopressors is done in this particular example. So you see that they are not enabled because the first one is not completed. And also I show over here that based on the patient, I see a female patient detected at least. That's really a technical task to show that we can take from the context from the patient, show that's there. And the people that observed very well saw that I have Jane Workflow as my patient, and she is indeed a female. Can we go to the next one? So you see over here also what I mentioned, the fire path. I made a real fire path expression on the sentry, and I say from okay, is it a female, then that task should be enabled, and it was available over there as being shown. And the last step, one more, boss. Oh, I thought that I also showed that when I completed the first task, the other three were enabled. So what is then under the hood? As soon as we provide the workflow definition to a workflow capability, it makes an activity definition or a plan definition, puts it in the Firestore telling this workflow is available. The application can read that definition and say, okay, I want to activate an instance of that one by creating a care plan, telling I want to activate this workflow for that patient. That is recognized by the workflow capability. It will start that workflow in the engine and react by updating the care plan as given in the presentation and providing all the tasks that are want to be shown to the application in the Firestore. The application will render those tasks, update the states, and that is written back by the workflow capability to go through the workflow. And as also been shown quickly, we can react on the context by taking off the data elements, like the patient I've shown, but there can be also all observations for the patient or other information. By means of fire path expressions, we can use that and leverage that in the workflow definition. I think that will demonstrate end this demonstration. So, Bas, I guess we're just in time.
Yeah, we had to quickly go through it. We copied screenshots on the slides, obviously, but it is a running prototype in software. It's not we're not cheating here. Then why we like to invite to come and present this work in the showcase session is that we would actually want to reach out to the community, and this research work that we've done is by no means Philips specific. As you've probably seen also from the demo, and we would be very interested to also start an open source community, or maybe it's already available, we just don't know, we're not aware of that, within BPM plus Health, to maybe drive this further with some other members as well, where either from industry or academic partners, where we all can contribute to such an enabling solution that we've built here, or maybe these partners bring in enabling solutions that are even more mature and further ahead than we are, so we can combine the best practices from all of that. So our question actually is, and I hope we have at least a little bit of time, does that exist in the current community, or are you interested in that to go that direction? Would be happy to hear some responses on that. Thank you.
This is Ken. I can jump in on that. So I'm the camera on. So first, thanks for the presentation. I think that the bringing together of FirePath and Fire and BPM and CDS. I mean, that is absolutely a space we're very interested in. I was just doing a quick look. Unfortunately, the two co-chairs of our process automation enablement, they just finished their session, but they're not on this one. But that's probably the most natural work group. They are working on some open reference implementation activities now. And the idea of bringing this project to that crowd and fostering that, I think, makes a lot of sense. we're not directly an open source community, but we absolutely want to support open reference implementations of the specs. So I think the interests are absolutely aligned. So I'll drop my contact details in the chat, and then we can figure out the right way to get you inserted in this. But I appreciate the interest and the willingness to contribute this. I think that's fabulous, and we certainly want to take advantage of that.
Okay, that's very great. Very good to hear, Ken. And yeah, there's no time now, but we'll then follow up after the session and discuss a bit further. Thanks a lot.
Any questions for Bas and Patrick? We have time for one question during the switchover break. So we have a 5-minute switchover break. So if there is one question, we could entertain one question if there is one.
Yes, my question is, did you implement that with monitoring? So because it is very important to start such a protocol as early as possible, because that reduces mortality. So it is only valid, or it is most valid, it's better if it were integrated with as an automatic routine in monitoring.
Mm-hmm. Yeah, so this work, as Patrick also said, was based on some example solutions that we indeed have in the ER. So that would also be with monitors involved. But our work was not specific to the application. So we tried to focus on the enabling part, the workflow capability, setting that up. Because many other solutions, this was an example of a sepsis protocol indeed for our emergency care. But we also worked, for instance, on treatment adherence in sleep and respiratory care, or even on some operational pathways through the hospital. So the strength of what we're aiming for in this research work is that you can build such an enabling software service in this way that can actually support all of these kinds of protocols, whether it's emergency care and patient monitors, or a dashboard in a hospital for operational purposes. It doesn't, in essence, really matter for the, let's say, the enabling part under the hood.
And indeed, we are aware of the fact that in such setting, that a good trigger to start at the right time is important, but that was not part of this exercise.
Both Patrick and me do not have a clinical background, but a software background. That's important to know.
Okay.
Well, did you have a follow-on question?
No, I think this is the real importance is that we bring it to clinical value. And so, of course, it's good to have it inside, let's say, something which works automatically. And since normal ward monitoring will come up as early as soon. So we need to get such, let's say, background specific parameters run to work. So it's a good way that Philips is entering this. And so I'm much more interested how they position it. Okay, if I need to start such a protocol by my own, then I could do it also by paperwork or something. So it needs to go automatically. That's very important for me.
Yeah, and you're absolutely right, but that is the solution development on top of that. So the applications that would use that, those applications have to make sure that the engine is started at the right time. And the protocols are loaded. By the way, we do not expect that our customers will define the protocols themselves, because no matter how good our modeling tools are, it's still quite complicated if you don't know what you're actually doing. So we believe that we would still, together with the customers, design those protocols and load them in the system based on the needs that a customer would have.
Okay, thank you, Bas and Patrick. Thank you very much for this great presentation. It's very refreshing to see Philips being interested and following a very similar path than the community here at BPM Plus Health community has been taken. So I look forward to working with you guys.